Now, by this time, we have captured this image by setting up camera, making robotic vision cell layout. Image has been captured. So what is first stage? What we do first? That we will be discussing here. Now image pre-processing means they are the basic operations. They are basic operations which are performed when image is received. Now what are basic operations? Suppose we have captured image through camera. First thing we want to check whether its contrast, brightness is correct or not. Image must be smooth. Image must be equally managed. Then and then objects can be highlighted and recognized. Another thing, we need images in particular size. We need particular highlights in that particular image. So brightness and geometric transforms, actually these are mathematical transforms. They operate on image. They perform operations on image. That's why they are said as transformations. Now pre-processing means enhancing information or enhancing useful information for further analysis. And it has to be done in first initial operations. That's why it is said as pre-processing. Real processing will start afterwards. But initially, whatever useful information is required. Now in our captured image, first thing, there is a lot of smoothness is required. So we have noise, like you can see dots are here, less clarity, imbalance in brightness and contrast. Then if I apply image edge detection, I'll not get shapes of the objects properly because there are noise, there are too many problems in this image. This image is not smooth as this image. So if I have not performed this pre-processing operations, later work, this will be problem for us. Our region of interest may be corrupted. Our region of interest may have problem. So this type of deformities are to be removed in this pre-processing operations. Now, brightness transformations are done by basic image processing techniques like point processing, neighborhood processing, position variant or invariant processing, enhancement and restoration. In lab, we have learned what exactly is the point-to-point processing. In point processing, we scan every pixel of the image. Then we apply statistical transforms. So we correlate each pixel brightness with its neighborhood either or all. So neighborhood processing or all points processing. One of the technique is called as histogram equalization. We have done in practical this. So wherein we check what is profile of the image, whether image is dark or bright, whether image is low contrast or high contrast. Accordingly, we perform histogram equalization operation and we see that our image must be available in greater transform. Now this is what transform equation. Consider one point, one pixel. Now these are gray levels of that points. And we apply these mathematical conditions to the transform function. We have learned this in lab. We have performed edge detection in lab also. Now practical meaning of this, for example, we are checking suppose tire pressure level. Then we need, now in this image which is captured, you can see many details are not correctly captured. This all thing, this all area is totally black. When we enhance this image through point processing, now you can see this tire, other details are again highlighted. This text is highlighted, right? This structure or this texture is also highlighted. So still we can again modify this image and go for better also, and this can be again reprocessed. Okay, see now this is one other example in biomedical. So you captured some image and then by equalization you get this image. This is totally dark image because light was not sufficient. See that behind this face is there, but that face is totally black because this is very dark image. After equalization you can see it is better or can be seen as a better. You can apply specific histogram also, and that particular area or particular level you can perform and improve the clarity ahead. Please refer our lab histogram equalization. We have done programming in this case also, and in that lab these details are explained in more details. Now let us turn to geometric transformations. Yesterday we were talking camera position. We are talking about timing of the capture. All of us know image or video, it is on one click it is start capturing, or mostly image is that particular small time distance. Whenever we press shutter, it is momentarily open and we capture all the image. Now we need to check in our image, captured image, various types of distortions are there. For example, in yesterday's problem, we were expecting our image in the scene grid like this. But whenever, because of the distance or because of the vibrations of manipulator, because of camera movement, many times we get shape distorted like this. Now geometrical transformation will allow us to recover that image into grid. Various types of geometric distortions are there, like panoramic distortion, skew, that image is stretch, or perspective type of operation. So geometrical transformations, again they are mathematical transforms, and they will convert image which is distorted to recovered image. Now these transformations are having various mathematical bases. General equation, that is what we say transformation model. Polygonal transformation or polynomial transformation will apply polynomial equations to each of pixel. There are some other categories like bilinear transformation, affine transformation, method of moments. Further other methods are also there, where we can resolve this all using these transformations. Apart from this, basic computer graphics allows us basic transforms, that is graphics transforms like rotation, skewing, orientation, scaling. This also we have done in lab. So because of this also we can realign image, we can realign grid or our required image. This all is a part of pre-processing. Suppose I have captured image and origin is shifted. Now this is real time process. Something is coming on conveyor. At that moment something happened. What you will do if you reject that object? So you need to have pre-processing. That's why every every time we apply normalization operation and grid will be normalized to 0 0, whether it is distorted or not distorted. So we take care in the programming and sequencing of our operations that every time scene grid will be aligned to the 0 0. Some more applications, like higher applications, yesterday we were talking about topological path planning, wherein we use radars, synthetic aperture radar. So it has given you so many parts. So you have to extract that nodes. You have to simplify the nodes, landmarks, or many other parts. So this is also called as a registration, because we are extracting that landmark characteristics from this SAR or radar image. Further, more applications are there, like in driverless car, blind spot detection, capturing position on the road using lidar, radar, or camera. Some more operations like removing, shrinking of the image or enlarging of the image, adjusting the brightness simultaneously. These are some more operations.